Hello everybody and welcome. I have decided recently to learn a little bit of Arduino and I got the starter kit. I came across a few projects that gave me an idea, right? My server chassis came with this very useless LCD screen. So what it basically does is there's a thermometer, but it's just behind the screen itself, so it's good for nothing. It basically is picking up the heat from the last hard drive over here. Then it has this runtime that counts no matter what's happening with your computer, and it just loops after 999 hours. And these two fans here, they rotate when you are using the chassis fans, but they are super loud, and I replace them with an Octus controlled by this fan controller on top here. So the first project that caught my attention was the thermometer one. You can basically see on the screen the temperature of the thermometer based on its voltage. On the second project, you drive a buzzer, right? And that's project number 6. And then on project 11, you drive the LCD screen. So I combined them all together and wrote a bit of software to drive everything at the same time, and also to help me write better to the LCD screen using a library that I used on the internet. So the Arduino code is very simple. The main loop writes the characters that you are receiving from the computer, except a character that I chose, in this case the ampersand, that if I get an ampersand, it will beep instead of displaying characters, right? And the reason why I did that was in case the computer is out or the application crashes, I can get a beep in case the temperature goes very high, or in case, I don't know, the operating system crashes or something like that. And the second function I took from Stack Exchange. So what happens is this LCD screen actually has 18 positions in the memory, or 19, but it only has 16 characters, so 3 of them always get lost in the next line. And I thought of handling this in my main application. But after further thought, I realized that better would be to just handle it in the screen itself. And of course, the last part of the main loop sends the voltage from the thermometer back to the system, right? And I'm doing it this way so I can change the baseline calibration of the thermometer and don't have to remove the Arduino from the chassis and re-push the software in case I need to do any changes there. Now, luckily for me, my daily driver at work is FreeBSD, and it matches TrueNAS that I'm running on the server. So the code that I wrote, it's not very pretty because, well, I'm not really a good programmer, but it is so far doing the job. And I will later on add functions to collect information about the virtual machines running in TrueNAS, and also the status of the jails, etc. So what do we have here? So there is a bunch of code to initialize the serial port, and it works both on Linux and FreeBSD, right? I have a small function here to just read the temperature, so it reads the buffer from the serial port. If it is the voltage, it will just do the conversion from voltage to temperature in Celsius and return it. Then I have a function alert to just send an ampersand to the serial port, and that makes the buzzer beep. And then down here, what I do first, collect. Sometimes I use FreeBSD API calls, and sometimes I just run the program and parse the output. Yeah, so here, for example, I get the number of CPUs, right, to calculate CPU usage. Then, of course, we have like free memory, swap information, and you see, I give up on trying to figure out the swap information using the native API, so I just run swap info kh and extract the, I basically parse then the output, yeah. Then of course, for every function, it then saves the output in a string, and I have some alerts set. So for example, if you have low swap, the LCD will start looping 10 times, so you have the alert on the screen for longer when you look. So I collect uptime, the power on time, right? And also I do another function here to see the smart status of the disk. So it will just every loop run smart CTL for each hard drive. I need to do something about it, but for now the list of hard drives is hard-coded, but it is doing the job, right? And if you have an issue, then of course it should ring the buzzer and blink that some hard drive is failing smart tests in the LCD screen. Then here down, I have the code to read the serial port. This is not in use because I already made a separate function, but I left the code down here inactive as my reference. Then the operation is very simple. Of course, the first thing here is to connect it to the server, as you can see here, right? And it will power on automatically. Then you run the application, right? It doesn't output anything to the screen. You could hear the beeper being tested. And then you get the data on the screen. Now I have set my workstation here to start assembling the board to not waste this prototyping board I have here. And after I'm done with work, I will solder everything together. So a few hours have passed, and well, I'm very bad at soldering, but here's the result. I have this ribbon cable here that goes to the board, so I can have actually the board, right, separated from the screen, because the screen is on the bottom of the chassis, right? So otherwise I can't. You can see the screen is updating fine. If I write something, then it shows. And if I send ampersand, it will beep. And the ampersand doesn't get printed. So a while has passed, and I have connected my thermometer here. This is just solder wire connected to the board. And if you look at the laptop, you will see that it's receiving the voltage correctly. I've done a few tests already, and if you do the ampersand, yeah, it beeps. So it's all in order. I'm gonna wrap this up for today and tweak the software a bit longer, and in a few days or weeks I should have it in the server. Okay, this looks better.